Okay, so I wanted to talk a little bit about compound interest. Now we're going to go back to that example where you invest $8,000. No, I said $4,000, didn't I? Sorry, $4,000 at 8%, but instead of simple interest, now it's 8% compounded quarterly for 3 years. Okay, so the new term there is compounded quarterly. What does that mean?
4 times a year.
4 times a year, or every 3 months, they calculate the interest and they add it in. And then in the next quarter, you get interest on your principal plus that interest. That's where the term compounding is you're getting interest on top of interest. That's compounding the balance. So let's look at our quarters here. In quarter 1, to find our interest, it's going to be 4,000 times 0.08 times 1/4, right? Or 3/12. So that's going to be $80 in interest. So our ending balance is going to be 4,000 plus 80, or $4,080. Well, in quarter 2, how do we find the interest? $4,080 times 0.08 times 1/4. Gives us $81.60 in interest. $4,161.60 in interest is our total balance. Well, how many times do we have to do this to get through 3 years? 12 times. 4 times a year, because quarterly, for 3 years would be 12 times. I don't want to do this 12 times. So let's look at a shortcut. First thing we're going to see is right here. This is always 0.08 times 1/4, which is 0.02. What that means is 8% annually is 2% per quarter, right? Now the other thing is we talked about that percent increase before, last hour. If it's a 2% interest, that's 2% increase. So what we can do is take that $4,000 principal and find 102% of it to get the ending balance, right? Let's try it. Let's see if it works. 4,000 times 1.02, that's 102%, is $4,080. Will that work for the second quarter? 4,080 times 1.02, $4,161.60. That is correct. How many times do we have to multiply by the 1.02? 12 times. Do we have a function in math that allows us to multiply by the same number over and over again? There it is, to the power of 1.02 to the power of 12. So 4,000 times 1.02 to the power of 12. 5,072.96. What? It's 97. You're right. I should round that up. Now remember, simple interest, it was $4,960. So you get an extra $113 almost because of the compound interest. Okay, now just because I feel I have to show you this example. Now for this group, most of us are a little bit beyond the crowd that this is most applicable to, but we all have kids and stuff that it'll apply to, so if you're like me, you missed the boat on this one, or you tried to do it and messed it up. But you've got kids that you can show it to that might be good for them. So let's say you get out of college and you are 23 years old. And while you're in college, of course, you're living kind of cheaply, either sharing an apartment or still living at home or whatever, driving that older car, that you've already got paid for and don't have to make payments on. You get out of college and you get that first good job. And most people, they move into a nicer place, they might buy a new car, get a better car and start making payments or whatever. But what if you stayed living cheaply like you were in school and just saved money? How much money do you think you could save in a year? Oh, yeah. I think 4 or 5. What's that?
Quite a bit.
Quite a bit? Yeah. Let's go with 5,000. That's quite a bit, but it's not impossible. If you go from, working for $8 an hour somewhere and struggling through school to now making $11 or $12 an hour on a 2,000 hour a year, that $2 an hour raise is $4,000. So it's not, and then you take all the expenses of school that you're not paying anymore, not buying books or whatever anymore. $5,000 is not impossible. For most of us, the IRS has said you cannot, or not the IRS, Social Security has said you cannot draw full Social Security until at least 67. The younger you are, the higher that age goes. For every month, or for every year you were born after, I think it was 1968, it goes by one more month. So most of the people that are at this age group, it's going to be at least 68. Let's say they're going to retire at 68. So that is 45 years, right? So if they take that $5,000 that they saved at 23 years old, just that 1 year, nothing else, just that one $5,000 thing, and they put it away in an investment, the average return in the stock market over a 40-year period is between 12 and 13% per year. Now, right now that sounds impossible because a lot of us are getting like 0.3% on our savings accounts. But my investments that are not in savings accounts are terrible. My market investments are still making 8-9%. And this is in a bad spot in the economy. So let's figure 12%. We'll go on the conservative side. So $5,000 times 12%. Well, 100% plus 12% is 112%, which is 1.12, right? So 1.12 to the power of 45. Now, before you punch this in, anybody want to guess? It'll shock you. 819,938. Almost $820,000 in your retirement out of 1 year of 5,000. Let's say that this person gets out of school at the age of 23 and says, no, I want to play with my money. I want that nicer house. I want a better car. And they wait till they're 33 years old. And then they save that $5,000 and put it away. Well, now it's only going to sit there for 35 years, right? It drops to $263,998. It drops to less than 1/3 the amount. Well, let's say you really mess up You get to be my age. They're moving furniture upstairs. So at 43 years of age, I only have 25 years to go. I only get $85,000. No, that's just 5,000 once. That's not per year. But here, my $5,000 at 45 is worth about 1/10 or 1/9 of what their $5,000 was worth at 23. Here, I'll show you this just because I think it's fascinating. So, I mean, youth is when you're looking at investing, youth is so important. So let's look at your age. Let's start out at 21. And we'll take this up to 67. Right there. Let's invest that $5,000 a year. Computer's running really slow. There we are. So we're going to invest, get over there, $5,000 a year for, well, it ends up being 47 years. At 12%. Anybody want to guess how much this is going to be at 67? That 5,000 every year?
Over $1 million. A couple million.
About 8 million.
Holy.
Yeah, it grows, and you can see how much it jumped every year in the last few years. It really jumped.
Is the interest rate really that stable?
If you go to a professional investment planner and have them help you with your investments, yeah, you can. I mean, you'll have years where you lose 15, 20%, but you'll have years where you gain 40%.
I know a kid who got in a really bad car accident when he was in high school, and he turned 18, and they handed him a check for just over $3 million, and he spent it all in a year.
Let's look at another situation here. Let's say this person, instead of starting to invest at 21, says, I want to play for a while. So for 8 years, they play with their money, and at 29, they start putting their money away. Where do you think they're going to end up compared to this person that started at 21?
$4 million.
About 3.4 million. Again, about a third. Here's where it's really... So let's do it the other way around. Let's take this person here, and they're going to save for 8 years, and then they're going to say, I want to play with my money. So now this person over here, in the second example here, the 3.4 million, they started at 29, so they were saving for 39 years, 38, 39 years. Person that I'm holding my mouse on right now, they only saved for 8 years, and then they took the next 39 years and played with their money. They end up way ahead. That first 8 years is worth more than the next 40.
That's crazy.
It is crazy, but that's the power of compound interest and time. In fact, let's go one more here. Let's take this one back. So they're paying in for a full 40 years, and this person only paid in for 7 years instead of 8. Oops, what did I put in wrong there? I put 50,000. Yeah, that's not fair. Okay. you can see this person's still ahead. That first 7 years is worth more than the next 40 years. So for those of you with kids, I used to actually advise friends, and they thought I was nuts. They had like college funds for their kids, and they only had like $10,000 or $12,000 in there. Well, that's not going to pay for their college. That'll get them through the first year, and then they're going to have to take out student loans anyway. Rather than giving them that $10,000 for college, convert it into IRAs. If you put that $10,000 in over, now the only qualification for an IRA, a retirement account, is you can't put away more than your kid makes. So if your kid only makes $4,000, you can only put away $4,000 for them in a retirement account. But let's just say, okay, you put away $12,000. So you put away $4,000 a year for them for 3 years. And then you make them, so instead of giving them the money for college, you invest it in those retirement accounts and you make them take out student loans. They have the rest of their life to pay off those student loans. They already have almost a $2 million retirement account set up. So their retirement's paid for, so they have their whole life to pay off the loans and they don't have to worry about saving for retirement. And it's a lot easier to pay a loan than it is to force yourself to put money away. So that's just my little, I'll get off my soapbox. I'm done preaching, but I have to show that. I mean, every year I feel I say, I'm not going to show it. It takes too much time, but I have to show it because,
That's amazing.
yeah, the power of compound interest is just ridiculous. Okay, well, we have a fun thing coming up on Thursday called Test 3. It's fun for me. What makes you guys think this class is about you? You guys are here to entertain me for 8 weeks now.
When is our last day of class?
It'll be 3 weeks from this Thursday. So I think it's like August 3rd or something like that is the last day of
That's
class.
what it says in our thing for our final test,
Yeah.
but
August 8th?
Yeah, Tuesday.
Let's double check.
I think that's the last day of summer school.
I think for this
I have no
class,
idea, I just-
well, we can certainly find that
I
out.
saw that our final test was the 3rd, and I was
Yeah.
like, that's 15, right?
I'm pretty sure it is, but let's take a look. Unless they put an extra day in there to make up for the 4th of July, but come on. I'll probably pause this while we're looking up. So yes, August 3rd is our last class.
And then the first day of the fall?
First day of fall is August 21st is when we come back. You guys come back. 25th is orientation. 28th is your first day of class. I do recommend, if this will be your first full semester of classes coming up this fall, that you do come for that orientation. There's a lot of stuff that's really, really big that helps out. That is the 25th, yep. Okay, so review for test 3. The first thing that we need to review for test 3 is operations with algebraic numbers. What do I mean by that? Well, things like 5x squared minus 11x plus 9 minus 8x squared plus 3x minus 7. So we set it up just like we would whole numbers, but we are subtracting here. Remember, be very, very, very careful with the negatives. So we are subtracting. So this is 9 minus a negative 7. And I always write it out. 9 minus a negative 7, which is going to become 9 plus 7, which is Positive 16. Negative 11 minus 3, which will become a negative 11 plus a negative 3, which is negative 14x. 5x squared minus 8x squared, 5 minus 8? Negative 3x squared. Of course, adding is the same way, only it's a little simpler because we're adding and not subtracting, right? Might be asked to divide. (28) to the 5th y squared minus 35 x to the 3rd y to the 5th plus 21x y to the 8th divided by 7x y squared. So when we divide, what do we get first? 28 divided by 7 is 4x x to the 4th y. Y cancels out. Y squared divided by y squared is gone. Cancels out. Negative 35 divided by 7. Negative 5x second. Y to the 3rd. Very good. 21 divided by 7. Positive 3, x cancels out, divides out, and y to the 6th. There we go. That's not so bad. What's that? I'm sensing a complete lack of faith here.
Oh, no, I have faith.
You're starting to hurt my feelings a little bit here. Something like that, how do we do it? You could FOIL, you could just keep, distribute that, then distribute this, right? Or you could set it up and do it the long way. You'd put the 2x minus 7 under here and do negative 7 times 9, negative 7 times negative 3. You can do it that way. Which way do you guys prefer? Do you prefer to do the distributing with the FOIL type, or do you the FOIL type? Anybody else have any strong preferences? Okay, so let's start here. We got 2x times 5x squared, which is 10x to the 3rd. 2x times negative 3x. Negative 6x squared, yes. And 2x times 9. 18x. Now when we move to the next digit, we've got to be careful to line things up. Negative 7 times 5x squared. Negative 35. And it's x squared, so I'm going to put it under the other x squared, right? I could put it over here and then just combine them, but it's easier if I put them under. Negative 7 times negative 3x. Positive 21x. Negative 7 times 9. Negative 63. So now I've got negative 63. 18x and 21x is 39x. Negative 6x squared and negative 35 is negative 41x squared. 10x to the 3rd. What do you think? You also need to be able to do operations with decimals. I'm not going to do too many of these because, well, you just punch them in your calculator and double check them, make sure you don't hit the wrong key. Remember we talked about that decimal key, and some calculators it doesn't show up until after you hit the next number, so punch them in twice just to make sure you get the same answer each time. But the one that I do want to go over is one that looks like this. 0.02 to the power of 5. How many decimal places would you expect this to have? Well, there's 2 decimal places here now, right? So the power of 5, I am expecting 10 decimal places. There's 2 decimal places here to the power of 5. You multiply the number of decimal places by the power. Because 0.2 squared, that's 0.02 times 0.02. I should say 0.02 squared, I should have said. Is 0.02 times 0.02. There's 1, 2, 3, 4 decimal places. 2 times 2 is 4. That's 0.0004. This is 0.0000000032. Why do I bring that up? Well, because your calculator might give you something funny. Like that. 0.02 to the power of 5 and 3.2 e negative 9. What's that mean? Yeah, the negative 9 means the decimal point has to go 9 spots to the left. So it's 1, 2 is at a 0, 3 is another 0, 4, 5, 6, 7, 8, 9. Now there's not 9 zeros, there's only 8 of them. But you had to go 9 places. The first place was the 3. Then the other 8 places had to be filled with zeros.
I did it right, but it just left off the 2.
Oh, because yours will go to 9 decimal or go to 9 places.
I did 0.02 to the 5th.
Okay.
It gave me all the zeros with the 3, but not the 2.
Yeah.
What model calculator do you have?
TI-30X.
Okay, you might be stuck in a float. Let me see your calculator for a second.
Yeah, 'cause I got the same kind she does, but
Okay. Okay, so you've got it set to round. Let's see if there's a mode here.
You did points. I did 2.
Okay, I'm not seeing the mode setting on here. I know there's a float setting on here, and then there's a, there it is, fix. Oh, that is your default setting, is to display it like that. Now what I'll do is I'll just make sure that the one I put on the test has few enough digits that it'll display it on your calculator.
thank you. How can you give it to the power of 5 though? And stuff like that.
The power of 5, you've got that caret key on your calculator. It's over on the left side here. It looks like this.
Okay.
So you do 0.02, you hit that key, and then 5. Okay. Other things we'll have to do for our test is you're going to have to convert a decimal into a fraction. So if I have 0.085, that's going to become 85 over what?
100. No, 1,000.
You're thinking percents. That's tenths, hundredths, thousandths, right? 3 decimal places, there's 3 zeros, right? Then, of course, we got to reduce. Both of those can divide by
25? No.
5. So this is going to be 17 over 200. You need to convert a fraction into a decimal. So for example, if I give you 7/16, how do you convert that into a decimal? 7 divided by 16. Was it 0.4375, I believe?
0.4375.
Perfect. You need to be able to convert a percent into a fraction. For example, 40% will become 40 over 100, and both can be reduced by dividing by 20. Gives you 2/5. So you have to do a percent into a fraction. You can also do a percent into a decimal. If I gave you 7.1% as a decimal, that will be
0.071.
perfect, 0.071. You move 2 spots. If I be able to convert a decimal into a percent, if I give you a decimal of 2.34, what is that as a percent?
234.
234%. Wonderful. And a fraction into a percent. If I give you 7/8, it's 7 out of 8. A percent is always out of 100. So 7 times 100 is 700. Divided by 8 is 87.5 out of 100, or 87.5%. Then you'd be able to calculate with percents, like we just did at the end of the last hour of classes, finding the missing number from the percents. You need to be able to solve equations with fractions. We've looked at a few of those. Like 3/4 x minus 2 1/8 equals 5.5. How do we solve that? Add 2 1/8. So 3/4 x equals 7 5/8. 5.5 plus 2 1/8 is 7 5/8. And then divide by 3/4, or multiply by 4/3 if that's how you prefer to do it. So x equals 241 over 3? No, that's not right. Is it? 7 5/8 divided by 3/4. 7 times 8 is 56, plus 1 is 61/8 times 4/3. 8 and 4 cross cancel, give me 1 and 2. So that's 61 over 6. That's 10 1/6. Questions? You'll also need to be able to solve equations with decimals. Things like 2.1x plus 6.3 equals what's that?
8.4.
Nope. There's no x on the 6.3.
Oh.
I'm still trying to think of the other number I want to put over there yet. My gears are grinding a little bit. Let's go 5.1. Is going to look ugly. Let's do 9.6. There we go. Let's try that. What would we do to solve that? Subtract 6.3. 2.1x equals 3.3. And then divide by 2.1. So x equals 1.571428. Repeating. If you just said 1.57 and left rounded it there, I'd be okay with that. Also need to be able to solve equations with parentheses. Something like this one. Where would I start there? Yep, nothing to do inside the parentheses.
Multiply the 2x and the negative 3 by 7.
So multiply by a negative 7. So the 5x isn't going to change. Negative 7 times 2?
Negative 15x.
Negative 14x.
Negative 7 times negative 3 is 21.
Negative 7 times negative 3 is a positive 21. You still have the 15 there. Now we're going to stay on the left side and still keep combining. What else can we combine there? Perfect. That makes negative 9x. Good. And then also 21 plus 15 is 36. That's all we can do on the left side. Now off to the right side. We'll do the 4 times 5x. 20x. And 4 times negative 8. Negative 32. Good. We've got the negative 9x and the negative 12. What can we combine?
20 and negative 9 is 11x.
20 and negative 9x make 11x. Negative 32 and negative 12 make negative 44. Negative 32 and then another negative 12 is negative 44, right? They both go the same direction. Then what? Add the 9x, I heard somebody say. We have an x on each side, so we have to get rid of 1. That was a negative, so we get rid of it by adding it. So 36 equals 20x minus 44. And then add the 44, yep. 80 equals 20x. And then divide by 20. X equals 4. 4 equals x. All that work for a 4. And then there are word problems. Remember, life is a word problem. It's true. Your boss is never going to come to you and say 3x minus 7 equals 12. What's x? It'd be nice if he did, but well, maybe not. Maybe that might be a hostile work environment. I don't know. But. The word problems, there's going to be a simple interest problem, like some of the ones we've done today. And there will be a couple of percent problems. Similar to ones we did today. I'll have an age problem on there.
You won't get it.
Like Alex is, I'm going to refrain from comment there. You guys got to understand, my brain thinks in cartoons. So when you make comments, like hundreds of cartoons flash through my head. And some of them aren't very nice. There might be some very deep sarcasm in some of them. So Alex is 3 years older than Pat. Stacy is, I want to make sure I did, 2 years younger than Pat. The sum of their ages is 52. Find their ages. Which age is going to be X? Pat. Alex then will be X plus 3 because 3 years older. Stacy? Well, we got to be very careful. Stacy is 2 years younger than Pat, so it is X minus 2. But I might say Stacy is 2 years younger than Alex. Then it'd be the X plus 3 minus 2, right? So you got to make sure you grab the right one. This case, it is younger than Pat, so it is X minus 2. So then we've got X plus 3 plus X minus 2 equals 52. What's next? Combine X, and X makes 3X. 3 and negative 2 make 1. So 3X plus 1 equals 52. And then subtract 1. Get back here. 3X equals 51. And then divide by 3. X equals 17. So that means Pat is 17. Alex is 17 plus 3. This is 20. Stacy is 17 minus 2, which is 15. What's that? So the perimeter of a rectangle is 7 inches longer. Oops, the perimeter. Let me try the length of a rectangle is 7 inches longer than the width. The perimeter is 34. Find the length and width. Well, we got the length and width of a rectangle, but the length is 7 inches longer than the width. So the length is W plus 7. P is equal to 2W plus, or 2L plus 2W. Well, P is 34. 2L becomes 2 times W plus 7 goes in for L. Plus 2W is just 2W. And then?
Multiply the 2 by the W and the 7.
Perfect. We multiply the 2 by the W and the 7. So that's 2W plus 14, right? And then? 2W and 2W makes 4W. And then? Subtract 14. 20 equals 4W. And then? Divide by 4. 5 equals W. W equals 5. 5 plus 7 equals 12. So the width is 5, the length is 12. What do you think?
It's just remembering the formulas.
Just remembering the formula, getting used to the patterns. I mean, the irony of word problems is the only way to get good at word problems is to do a bunch of them. So you start picking up on which word clues within the problems. And most people hate word problems, so they avoid them. So they're never going to get good at them. So just power through them and do as many of them as you can is the only way to get good at them. You had a question? Or did you have a question? Okay. Well, that is all I have for material for the day. So I'll let you guys have the last 20 minutes to get started on. There is a quiz today. Of course. A quiz that is due by 11:59 p.m. tonight. And there is a homework that is due for Thursday.
Can I ask you to go through question 31 on today's homework?
Oh, yes, we forgot that, didn't we? Question 31 on today's homework.
That's the only one I was really having, that was really kicking my butt.
Okay, let me see here. Assignment.
I know
7-11,
there's an easy
all
formula,
right.
I just can't get it in my head.
31, huh?
Yeah, it was,
Second to the last one.
yep, making the change. Figuring out how many.
China is a collection of coins that consists of nickels and quarters. The value of these coins is 385. Number of nickels is 6 times.
Yeah, that's the only one I really
Okay.
have problems with.
So you've got nickels, quarters,
Oh, I skipped it.
the number of nickels is 6 times the quarters. So if quarters is X, nickels is 6X. That's the number, right?
Right.
The dollar amount
Was,
is going to be 0.05 times 6X, which is going to be 0.3X. 0.05 because the nickel is 5 cents, right?
right, okay.
This will be 0.25 times X, so just 0.25X. So 0.25X plus 0.3X equals $3.85, which is what your numbers might be a little different, but that's the one they gave me. So then you combine those, that's 0.55X equals $3.85, right?
We divide by the 0.55.
Divided by 0.55. So 385 divided by 0.55. Seven. So X equals 7. So that means there were 7 quarters
And then multiply 6 times 7.
and 42 nickels.
I knew it was something stupid. I was almost just gonna break out my piggy bank and start throwing out
Start counting them out.
change on the floor.
That's one possible
Number
way.
21 or 23 on the homework.
23, okay, let's take a peek.
It said get rid of decimals by multiplying by a power of 10.
Okay. And that is always one option on these. Kind of like how we did the common denominator to get rid of fractions in some of them. Well, you look at this, the most decimal places you have is 2 in any one of these problems, in any one of these numbers, right? So if you multiplied the whole thing by 100, it gets rid of the decimals. So 100 times 0.14x is just 14x. 100 times 0.25 is just 25. 100 times 1.37 is 137. And then you can solve that equation. To me, however, with decimals, decimals are easy enough to work with. I really wouldn't mess with that. I would just subtract the 0.25 to get 0.14x equals 1.12 and then divide by 0.14. You get x equals 8. But this is one method. It's kind of like using that common denominator, multiplying by that least common denominator to get rid of all the fractions in an equation. It does the same thing. Any others you want me to look at? Okay, I will make sure the test is sent out tomorrow so you guys can come in and start early on Thursday if you want to.